Okay, so hello. Hello and welcome sa ating panibagong lesson. Welcome to our class. And here is our new lesson which is the current, resistance, and resistivity. So tatlo lang and we have an additional thing which is the EMF. But we will be discussing it in our at the later part of this lesson. Okay, so without further ado, so let's start discussing what are these components. We have the current, resistance, and resistivity. But before that, we have to start first with our resistance. Okay, so resistance with the symbol R, it is the act of fighting against something that is attacking you or refusing to something. So that is resistance. So this is the definition from Merriam-Webster. Okay, so it is the act of fighting against something that is attacking you or refusing to something. But when it comes to electricity, resistance is something that prevents or slowing down or resisting the electric current that is flowing in our circuit. Okay, so in electronic circuit it is found in a resistor whose job is to reduce current flow, adjust signal level, divide voltage, and etc. So these are the primary goals and primary work or job of the resistor to resist current flow, adjust signals, and etc. So those are the things that the resistor is doing with its job as the resistance. Okay, so in electricity, when it comes to resistance, its primary work or what it do or what it does is to resist the electric current flow. Sir, why? Normally, if you have an overflowing electricity and you don't have any resistor in it, it might overcharge or the electronic device um, tend to receive more electrical charges or electricity, and when it does receive more than it usually do, there will be malfunctions that will happen, and the resistor's job is to lessen the blow. Okay, guys. So for example, it in other terms, it can be the cushion. Okay, so for the device to lessen what it usually receive. Okay, what it usually receive. For example, we have a 10 voltage source, and it flows in our electric circuit, electric board, and the electronic device is receiving should receive the lesser, and then the resistor should do its part to lessen the electric current that is flowing in our electronic device. Okay, so that is what the resistor or what is the resistance is uh, played its part. It's playing its part in our electric circuit. Okay, so we have our formula of resistance, which is V is equals to IR. We have here our V is equals to voltage or volts. I is our current in amperes, and our resistance has a unit of omega or ohms in other terms. Okay, so in engineering world, when it comes to resistance, omega is read as ohms. Okay, so that is the symbol or the unit of resistance. Okay, again, resistance has a symbol of R, while its unit is ohms. Okay, so we have here an example. Okay, so a resistor carries a current of 0.2 amperes when the potential difference across it is 6 volts. Solve for the value of the resistance. So we will be solving for our resistance using our given values is. We have your zero point 0.2 amperes and 6 voltage in our electric circuit. Okay, so guys, please proceed in answering this. Medyo maaga, mabilis, di ba? Sige lang, tuloy lang natin. And please, if you have if you have questions, please key it in our chat box, or in other terms, or in other if you have any other questions about our problem, or if you have answers, you may also key it in our chat box. Okay, so please. Okay, so let's try to solve for this. So we have here our formula, which is V is equals to IR, just what we are looking, this is the formula that we have been, that I have shown you a while ago. So we are looking for the resistance. So cross multiplying, we will have our formula of R is equals to V over I, or resistance is equivalent to voltage all over our current. So with this, we can solve for our resistance. So it's a direct substitution. We have here our 6 voltage all over zero point 0.2 ampere. So in this case, we have our resistance of 30 ohms. Okay, so with that, let's try to solve for this. We have 6 divided by 0. Okay, 0.2 So we have here our 30 ohms, or in this case, let's try to solve for this of 6 over 0.2. Still, we have 30 ohms. Okay, so I hope guys that you have get the answer of 30 ohms, and this might be a great help for you. So this is a familiarization of our formula, and I hope this is a big help. Okay, so let's move on to our next thing. We have here our current, or I, which is our symbol for current, I. Okay, so an electric current is a stream of charged particles such as electrons or ions moving through an electrical conductor or space. Okay, so we cannot see the current, but we can easily identify if there are current flows in our electric circuit. So one example here is the light bulb. Okay, so let's try this one. So sorry guys, I will be using the example of capacitance. Okay, so the capacitor. But take note that it is not the capacitor that I am highlighting here, but the current flow that our source that is giving to our light bulb. Okay, so let's play on this. Let's play this one. So we have here our light bulb, and we have here our dry cell or our power source. So let's connect it so that we can have a charge in here, and then once we connect our source to our light bulb, it lights up. Okay, so when it lights up, meaning there is a current flow from our source to our light bulb. If there is a current flow, there is an electrical transfer from our source to our light bulb. Okay, so that is how our electric current works. So as you can see, there is an electric current arrow, and it will be highlighted, or it will be shown here. So you see the blue arrow. There is where our current is flowing from our source to our light bulb. And when it reaches the light bulb will automatically receive the current and lights up. Okay? So, okay. So let's proceed in our next topic, which is the current density, or in other symbol, it is J. Okay, so it's easy to understand, or it will be easy to remember. When it comes to current density, just remember me. Current density, J. Napakabulok ng joke ni sir. Okay, so sige. Current density, or in other or in a symbol, it is J. The rate of flow of charge, through a cross section in coulombs per second is known to be current. Okay, so we have here our I is equal to Q over T. Okay, so current muna tayo dito. Current natin is charge all over time. Okay, so ampere is equivalent to coulomb per second. So considering a piece of connector, so we have here our wire. Let's say it is a wire. So if you are wondering, sir, why is it so big? The cross section, or the diameter of our wire is too big. So when it comes to wire, when you zoom it in, this is what it looks like. So it's like a cylindrical, it's cylindrical in shape, and the diameter of our cylinder is quite big. If you just zoom it in, for example, in a microscopic manner, zoom it in, this is what it will looks like. Okay, so we have here our length, we have here our diameter, and for our formula of current density, we have here our J is equals to current all over the area. So when it comes to cross section, this is where our area will play its part. So current flowing in a conductor per unit area is called current density. So that is where our area is going to play. Okay? So let's try to Solve for the current density of a copper diameter of 0.14 centimeters that carried 12 amperes. So again, guys, cross section. Okay, so we have here cross section. Okay, so cross section yung sinabi sa atin in our current density. So when it comes to cross section, we are talking about the diameter and its area. Okay. So we will be using that cross section. So in this case, this is where our current is passing, all in this circular area. That is the cross section. Okay, so let's try to solve for this. Solve for the current density of a copper diameter of 0.14 centimeters that carried 12 amperes. Okay, so sige guys, please try to solve for this problem, and let's see what we will be what will be the answer, or the the value that we are looking for. So, sir, solve for the current density of a copper diameter of 0.14 centimeters that carried 12 amperes. Okay, so please proceed in answering this question, and we will be back again. Okay, guys. So have you answered this question? I hope that you have answered it well. Okay, so let's proceed in answering this. So we have here our formula of our current density, which is J is equals to I over A. So we have here our J of 77993 ampere per square meter. So we have here our J of 12 divided by pi of 0.007 uh, square. Okay, so wait. Okay, so here, so let's remove this one. Isa lang zero yung kailangan natin dito. Okay, so let's try to solve this one. Okay. So we have here our 12 amperes divided by okay. Okay. Pi, and for the area, we have the formula of our area of pi r squared. So we have here 0.14 centimeters. Okay, so let's try to solve for this one. So let's try to delete this first. So we have here 0.14, and we are going to convert this into meters. Okay. Okay, so into meters. So we have to convert this one, multiply. So we have here 1 meter all over 100 centimeters. Okay, so we will be having an answer of, okay, okay, so it's 0.0014. Okay, so here is uh, our okay, wait. Okay, so 0.0014. This is 100 centimeters is equivalent to 1 meter. So we have here 0.0014. So in this case, 12 divided by pi. Okay, shift, and we have here our answer of 0.0014. Okay. So but we have to divide it by 2 since we are looking um, for our radius. So we will be having the answer of, okay, so we have a little mix up here. Okay. So here is our solution. So here we have here 12 divided by pi all over 0.0014 all over 2 squared. So in this case, we will be having an answer of uh, 7, 7, 9, 5, 3, 4, 4 ampere square meter. Okay, so here is the correction in our problem. I hope guys, please disregard this one. So medyo typographical error lang naman. Typographical error, onti lang. Nagkamali kasi tayo dito sa value natin dito, which is 0.00. Zero! May isa pang zero tayo dito. 7. Okay. So I hope guys that this part is clear. So we have here our correction, and I think it gives justice to our wrong input in our problem. Okay? Sige. So we have here electric current is the continuous flow of continuous flow of electric charge in a conducting path like a wire when connected to a source such as battery. Okay, so gusto ko lang ulit burahin to. And we have here another zero. Okay. So electric current is the continuous flow of electric charge in a conducting path like a wire when connected to a source such as a battery. Okay, so that is our current. So we have here our resistivity, which has a unit of which has a symbol of rho, RHO, RHO. This is how we read this symbol, rho. Okay. So it is the electric field strength per current density. Electric field strength per current density. So you have an idea here, guys. So we have here rho is equal to electric field E all over current density J. So I hope tama to. So yes, we have here our electric field strength all over current density. Rho is equals to E all over J. So we have here our formula E is equals over rho is equals to E over J. But in this case, we can still get the gist or the more detailed resistivity formula. Okay. So electric field strength all over J. This is just the general formula, but we can still turn it around, or we can still make this one a more detailed formula. So we have here our E all over J, which is the formula for our electric field is VA over IL. So in this case, try muna natin. So we have here our V over L, and we have our current density I over A. So here is our electric field strength V over L, and we have here our J, and we have here our J of current all over area. Okay, so we have here our formula cross multiply, or cross multiply. We have here VA over IL. So in this case, we have here V over I can also be read as our resistance R, and we have our formula of more detailed formula of rho is equivalent to RA all over L. Okay. So we have here our formula of resistivity, which is RA all over L, with the unit of our rho of ohm meter. So that is read, this is read as ohm meter. Ohm meter. Okay. Ohm meter, the unit of our resistivity. Okay, so we have here our a little simulation of our uh, resistance, resistivity, length, and the area. Okay, so we have here our resistance, our resistivity, length, and our area. So in this case, once we make our resistivity larger, as you can see, our resistance became larger also. When we enlarge our length, the resistance also gets larger also. Okay, so numerator gets larger, but when it comes to our area, when we adjust our area to a larger position, the resistance goes smaller. Okay, so if we adjust our resistivity to the lower part and our length, as you can see, our resistance also gets smaller. Okay, so when it comes to our area, in increase, nag-decrease naman yung resistivity natin, yung resistance natin. So in this case, we can safely assume that when we make our resistor, or we make our area smaller, our resistor will eventually get bigger or get larger in terms of its values. Okay, in terms of its values. Okay. Okay. So we have here another formula or another problem that requires your immediate attention. So guys, please try to please try to solve for this. A 2 mm wire carried a 12 ampere to a household appliance. So solve for the electric field in the wire. So the resistivity is given 1.6 times 10 raised to negative 8 ohm meter. So in other problems, we will be looking for the resistivity. Other values will be given. But in this case, the resistivity is given and we are looking for our um, electric field in the wire. Okay? So, sige guys, I'll be giving you time to solve for this and I hope this will be a good problem to practice your skills and your mathematical solving skills. Okay, so see you guys. I'll be leaving you here, and I'll be back when the timer is done. Okay, so please try to solve for this problem. Okay, so I hope guys that you're finished answering this problem. So let's try to solve for this. So we have here our formula of resistivity is equivalent to our electric field strength all over J. So we have here our electric field strength of E is equals to J times resistivity. So we have here our J is equivalent to I over A, or current all over the area. In this case, let's mix up with the current and current all over area multiplied to our resistivity. We will be having a formula of E is equals to current multiplied to resistivity all over the area. Okay, so we have here our formula of we have here our values of 12 times 1.68 times 10 raised to negative 8 all over pi 1 2. Let's make this 2. So this is not 1. 2 times 10 raised to negative 3 square. Okay, so we have here our formula of E is equivalent to 0.0642. Or let's try to solve for this. So we have here our 12 volts, 12 amperes, 1.68 times 10 raised to negative 8. Okay, all over pi, shift pi, and 2 times 10 raised to negative 3. So this is millimeters. Okay, that's why it is times 10 raised to negative 3. Don't forget our square. Okay, so let's solve for this. Okay, so another typographical error. So we have here our electric field strength of E is equivalent to 0.016 volt per meter. So we have here our value of E, which is 0.016 volt per meter. So this is the value of our electric field strength. Okay, so if you have questions regarding that problem, you may approach me or you may ask me how do we arrive at that answer. Okay, so next is we have our electromotive force. So EMF. So electromotive force. So it is the electric potential generated by electrochemical cell or a changing magnetic field. So we can get our electromotive force from a generated electrochemical cell or a changing magnetic field. So other we can get also to solar and to heat. Okay, in our heat. Okay. So we have here, it is the electric action produced by non-electrical source. So we have here example of electrical source, which is battery, dry cell, that is from chemical to electrical energy, from chemical energy to electrical energy. We have generator, mechanical energy to electrical energy. We have here another thing is we have I didn't write it in there, but you may jot this down. We have solar, okay, solar panels, solar energy to electrical. Another thing is we have the boiler. Okay, so heat energy to electrical. So all those four categories are can generate electricity from our from other forms of energy. So we have here the chemical, the mechanical, we have the solar, and we have the heat, uh, thermo energy. Okay, so that's the reason why um, in this case, as you can see, we have many source of electricity. We have the chemical, the mechanical, solar, and etc. and etc. We have also our wind power. So behind all those type of sources, all of them are called electromotive force. Okay, so it can generate from the source can generate electricity from other forms of electricity. Okay, so this is a big issue here in the Philippines. That's for the reason why most capitalists are using most capitalists are building private electrical sources, and they don't rely on the renewable energy for the reason that there won't be any profit from it. Okay? Yun nga lang talaga sadyang lulubog ang Pilipinas dahil ng mahal yung kuryente and all. And as you can see, we have many sources, but still we are paying a ridiculous amount for a minimum amount of electricity. So electromotive force, we have different types of sources, non electrical sources that can produce electrical action. Okay, so electromotive force, from the word itself, force. So as you can see, we will be using here the unit of Newton, but you guess it wrong. We will not be using any units that pertains to the force or in newtons. Okay, but in this case, when we talk about the unit of EMF, it is volts or V. So this is also the voltage. Since it came from the source connected to our circuit, it is rightfully to use voltage as its unit or volts. Okay. For the reason that it is the source. Where does the source what is the unit of the source in our electric circuits? It's always in voltage. So in this case, electromotive force EMF is using um, using voltage as its unit. Okay, so again, we have electromotive force, and how does it work? So we have here our dry cell. Here is our dry cell. Okay. So we have here our EMF, which is in 12 voltage. So it's just we will not be using the 12 voltage. I just put in there that it is indicated as 12 voltage. Okay. We have here our resistor and another resistor. I didn't name those two. They are both resistor. It's probably we have the same amount of the resistance they are having. Okay, and we have here our current that flows from the positive side of our dry cell going on a loop to our negative side. Okay, so we have here the first end for the and this is in 12 voltage. Okay, and we have here 6 voltage in this point, and we have 0 voltage at this point. Okay, so sir, why or how does that happen? Okay, so in this case, in this part, which is the 12 voltage, so since it is 12 volts, total voltage of our dry cell, it is right that we are experiencing 12 voltage in this area. Okay. So 12 voltage in this area. Sir, why are we experiencing 12 voltage in this particular area? So as you can see, there are no resistor, no capacitor, and no other circuit components that will receive the electric charge or the voltage coming from our dry cell. So in this case, we are having a solid 12. Okay, so solid 12 in this red dot also. Okay, so solid 12. But when it passes through our passes through in our first resistor, in this junction, we will be having 6 voltage. Sir, why? Why do we have 6 voltage in this junction? For the reason that this resistor has already taken part of the ever duty dry cell that is giving 12 volts, and when it passes through this resistor it will receive some of its voltage. That's why in this case the voltage here at the 6 volt part will be reduced from 12 volts to 6 volts. So I hope that you are getting the gist of it. So, sir, why does the last dot is zero voltage? Okay, so if you guess that the resistor has already eaten some of the parts of our ever duty battery, you are correct. Okay, so sir, why? Why are we correct? For the reason, same reason here in our first resistor. Same reason in our first resistor that this resistor is already taking part of the ever duty dry cell battery that is giving 12 volts, and 12 volts, when it passes through our resistor it will become 6 volts, and then it passes through to the other resistor, the last resistor, it will be all over, or it will be taking up zero. Okay, so zero tayo, zero voltage. Okay. Okay, so again, the EMF flows from uh, from a lower, from a higher, value to lower. Okay, so it flows from higher value to the lower value of the voltage side. Okay, so why? Because we have the resistors and other electrical components that will partake to its total voltage. Okay? Okay. So, let's see. Okay. So, I guess we are done. So, do you have any questions, guys, regarding our lesson for today? For the current, resistance, and resistivity. And also, we have here our electromotive force as our additional topic, additional component that we are going to look for. So we don't have any formula here in our electromotive force, but I hope that you guess it, that we have here our EMF, which is equivalent to 12 voltage, and that will be a part of our terminologies, and maybe we can use also the term electromotive force in our problem solving. Okay, so as you can see, it is being used as our the other term for our power source. Okay, so if you have any questions regarding our topic, so if so, please key it in our Gmeet chat box. Okay, so this concludes our lesson for today. I hope, guys, you have learned a lot. You have learned a ton, and I hope everything will be cool and good in our class. So thank you, guys, for attending the class. This is your Sensei JJ, and peace out. Bye, guys. Be legendary.